Unicode. In Python 3, strings are composed of Unicode characters. Unicode is a standard describing the representation of more than 100,000 characters in just about every human language, as well as many other specialist characters such as scientific symbols. It does this by assigning a number code point to every character. The number that makes up a string are then encoded as a sequence of bytes. For a long time, there was no agreed encoding standard, but the UTF-8 encoding, which is used by Python 3 by default, has emerged as most widely used today. If your editor will not allow you to enter a character directly into a string literal, you can use its 16 or 32-bit hex values or its Unicode character name as an escape sequence. For example, this is a 16-bit hex value for this E-like character which has a sort of a cap on it. And this is the 32-bit hex value for the same character. And this is the actual name of the character. And it is the Latin small letter E with acute. I don't know what that is, but it is what it is. Indexing and slicing strings. Indexing or subscripting a string returns a single character at a given location. Like all sequences in Python, strings are indexed with the first character having the index 0. Now this is very important that you remember that the first character of a sequence has the index 0. This means that the final character in string consisting of n characters is indexed at n minus 1. For example, A is equal to night, A 0, we get K because the first character has the index 0 and that is K. Now if we do the same with the third one, we get G. And as we can see that G is the fourth character and we use the index that is n minus 1 which gives us 3. The character is returned in a string object of length 1. A non-negative index counts forward from the start of the string. There is a handy notation for the index of a string counting backwards. In a negative index starting at -1 for the final character is used. So A -1 with the same example will give us T and A -4 will give us I. It is an error to attempt to index a string outside its length. Here the index cannot be greater than 5 or less than -6. Python raises an index error. For example, we get this error if we try to do so. Slicing a string this way produces a substring of a string between the characters at two indexes, including the first that is defined by I, but excluding the second that is J. If the first index is omitted, 0 is assumed. If the second is omitted, the string is sliced to its end. For example, A is equal to night, A 1 and 3. We get Ni. These examples are pretty straightforward. This can seem confusing at first, but it ensures that the length of a substring returned as Sij has the length j minus I for positive ij and has the length, and that it fulfills the condition S0 to I and Si to the last index is equal to S. Unlike indexing, slicing a string outside its bound does not raise an error. For example, A 3 and 10 will just give you GHT. And same with this example. To test if a string contains a given substring, use the in operator. For example, K and I in K night will give you true and K and I in night will give you false. So this means that this is case sensitive. String methods. Python strings are immutable objects and so it is not possible to change a string by assignment. For example, the following is an error. A is equal to night, and then try and change the first index, that is 0, to a lower k, we get an error. New strings can be constructed from existing strings, but only as new objects. For example, A plus equal Templar. We get, and then we print A, we get Knight Templar. Note the space. We have to indicate that there is a space. And then B is equal to black plus A from 0 to 6. Now what this will do is just add the first 6 indexes from A, that is this, and then we get a black knight. To find the number of characters a string contains, use the length built-in method. For example, A is equal to earth, length of A, we get 5. String objects come with a large number of methods for manipulating and transforming them. These are accessed using the usual dot notations we have met already. Some of the more useful ones are on your screen.